Hey guys, so welcome to our first class in Advanced Engineering Mathematics. So in this subject, basically yung pag-uusapan lang natin from start to finish is differential equations. Maybe you've heard of that term before in your calculus subjects, okay? Or baka yung iba nakalimutan na nila. Okay lang. Actually, itong subject na to medyo mabigat siya. So I suggest that you start reviewing your notes and lectures in differential and integral calculus. Ang kagandahan lang is maraming applications itong subject na to in other topics. For example, population growth, half-life of elements, carbon dating, mixtures, at iba pa. And syempre, sa field natin in civil engineering, meron ding application, yung differential equations. So, pagdating nyo sa structural engineering ng mga subjects, merong topic doon about beam deflection and column buckling. Okay? So, these topics involves differential equations. Kaya huwag niyong iisipin na walang kwenta itong subject na to kasi napakarami niyang applications, lalo na sa mga CE na mga subjects. Okay, so let's start our study of differential equations by first defining what it is. So, what is a differential equation? A differential equation is an equation containing derivatives of one or more dependent variables with respect to one or more independent variables. So, yung keyword natin doon is equation containing derivatives. So, let's write some examples of differential equations. First, we have the derivative of y with respect to x equal to cosine of x. This is an example of a differential equation because we have a derivative. So, yung dependent variable natin dito is yung variable y, dy, yung nasa numerator, and then yung independent variable naman natin is yung nasa denominator, y dx. So, that would be x. Again, based on the definition of differential equation, this equation is an example of a DE, or differential equation. Next example we have is y double prime plus k squared y equal to 0. Y double prime, that is just another way of writing the second derivative of y. Okay? So we have the second derivative of y plus some constant k squared times y equal to 0. Again, we have a derivative in our equation, therefore this is a differential equation. In the next example, we have the second partial derivative of v with respect to x plus the second partial derivative of v with respect to y equal to 0. Okay, so I hope familiar din kayo dito sa mga partial derivatives. So again, by definition, derivatives pa rin yan. So this is also an example of a differential equation. So last example, we have x squared plus y squared dx minus 2xy dy equal to 0. Okay, so that is also an example of a differential equation. Okay, so napakadali lang i-identify kung yung equation ba natin is a differential equation. Basically, titingnan mo lang kung meron kayong derivative. So, after natin ma-define kung ano yung differential equation, next na gagawin natin is i-classify natin kasi maraming mga types ng differential equation. First, we classify our differential equation by type. So, we have two types of differential equation. First one is the ordinary differential equation, or also known as ODE. The second one is the partial differential equation, or PDE. So, by definition, an ordinary differential equation is a differential equation containing only derivatives of one or more functions with respect to a single independent variable. Okay? Again, yung independent variable natin, titingnan nyo lang yung nasa denominator ng derivative nyo. So, for example, let's take the equation dy over dx minus 3y equal to e raised to 0.5x. So, we can see here that our independent variable is the variable x. So, e isa lang siya. Okay? So this is an ordinary differential equation. So next example will be the derivative of x with respect to t plus the derivative of y with respect to t equal to 2x minus 3y. Again, yung independent variable natin dito is the variable t. Okay? So we have two derivatives in our equation, but both of them is with respect to the variable t. So isang variable lang, isang independent variable. Therefore, ordinary differential equation pa rin siya. So for the second type, partial differential equation is a differential equation involving only partial derivatives of one or more functions of two or more independent variables. Okay, so dalawa or mas marami pa yung independent variables natin. So for example, we have the equation 3 times the second partial derivative of t with respect to x minus 4 times the second partial derivative of t with respect to y equal to 0. Again, our independent variables in this equation are the variables x and y. Okay, so meron tayong dalawang independent variables. Therefore, this equation is a partial differential equation. So next example, we have the partial derivative of m with respect to y equal to the partial derivative of n with respect to x. Again, our independent variables here is yung nasa baba ng derivative natin. So that is variable y and x, dalawa. Therefore, this is a partial differential equation. Okay, so next we will classify our differential equation by its order. So, napakasimple lang ng classification na to. Basically, the order of a differential equation, both ODE or PDE, is the order of the highest derivative in the equation. For example, we have the equation second derivative of y with respect to x minus 4y equal to the first derivative of y with respect to x raised to the power of 4. So, by definition, sa tingin nyo, ano yung order ng equation natin dito? So, kung titingnan natin, again, the order will be the highest derivative in the equation. So, we have two derivatives, the second derivative of y with respect to x, and then we also have the first derivative of y with respect to x. So, therefore, this equation is a second order differential equation. Okay, so, wag niyong iisipin na yung okay, so baka isipin nyo na yung order natin dito is 4 kasi raised to the power of 4. No, so mali yun. Again, yung titingnan natin dito is yung order ng highest derivative. So yung highest derivative natin dito is second derivative. Therefore, this equation is a second order differential equation. Next example, we have the third partial derivative of t with respect to x plus the second partial derivative of t with respect to y equal to 0. So, by definition, this equation is a third order differential equation. Now, if we go back to our previous classification, pwede rin natin itong i-classify by its type. So, here in our first example, this will be an ordinary differential equation. Therefore, this will be a second order ordinary differential equation. And the second example is a partial differential equation. Therefore, it is a third order partial differential equation. So, next classification we have is we classify our differential equation by what we call linearity. Okay, so classification by linearity. So, basically, our equation can be linear or non-linear. So, an ordinary differential equation of order n is called linear if it may be written in the form, yan, yung nakalagay sa taas. So, that is a of x times the nth derivative of y with respect to x plus a n minus 1 of x times the n minus 1th derivative of y with respect to x plus a of x times the first derivative of y with respect to x plus AO of x times y equal to g of x. So, if we are given a differential equation and then we can rewrite it to a form similar to this one, then that differential equation is a linear differential equation. For example, we have the equation y minus x dx plus 4x dy equal to 0. So, kung titingnan natin, at first, napakalayo niya dun sa form, okay, na nasa taas. So, baka isipin nyo na hindi ito linear. So, yung gagawin natin is, i-rearrange lang natin with some algebraic manipulations. So, first, gawin natin, i-divide natin yung whole equation natin by dx. So, we have y minus x plus 4x dy over dx equal to 0. And then, i-arrange lang natin ng kaunti. So, we have 4x dy over dx plus y equal to x. So, now we can see that this form is similar to the one above. Therefore, the given equation is a linear differential equation. Next example, we have y double prime minus 2y prime plus y equal to 0. So, pwede natin tong i-rewrite. Again, y double prime, so that will be the second derivative of y with respect to x minus 2 dy over dx plus y equal to 0. Again, this is very similar to the form above. Therefore, this equation is a linear differential equation. Next, we have x squared times the third derivative of y with respect to x plus x dy over dx equal to e raised to x. Again, same siya ng form doon sa taas. So, ibig sabihin, itong function na to is also a linear differential equation. Okay, so hopefully, madali lang i-identify yung equation kung linear ba siya or hindi. Okay, so if you can rewrite the equation with a form similar to this one, then linear siya. But if you cannot rewrite your equation similar to this form, then syempre, non-linear siya. Okay, so meron din ibang mga conditions that makes an equation non-linear. So first is if the coefficients of y dy over dx or up to the nth derivative of y with respect to x contain the dependent variable y or its derivatives. For example, we have the equation 1 minus y times y prime plus 8y equal to e raised to x. So, we can see that the coefficient of the first derivative or yung y prime natin, yung coefficient niya is 1 minus y. So, it contains the dependent variable. Therefore, this equation is non-linear based on that condition. So, next condition we have is if the powers of y dy over dx up to the nth derivative of y with respect to x, such as dy over dx squared or y double prime cube appear in the equation, then the equation is non-linear. We have this equation, the third derivative of y with respect to x plus y squared equal to 0. So based on this condition, so yung y natin, it is raised to the power of 2. Therefore, this equation is also non-linear. And the third condition we have is if non-linear functions of the dependent variable or its derivatives such as sin y or e raised to y prime appear in the equation. Okay, so for this condition, let's consider the function second derivative of y with respect to x plus sin y equal to 0. Okay, so we have the non-linear term sin y in our equation. Therefore, this equation is a non-linear differential equation. Okay, now we're done with the definition and classification of differential equations. Let's move on to how we solve differential equations. So first, let's recall that the derivative dy dx of a function y is equal to f of x is itself another function, f prime of x. So, for example, let's have the equation y is equal to e raised to 0.2x squared. So, if we take the derivative of this function dy over dx, so that will be equal to e raised to 0.2x squared times 0.4x. Again, I suggest that you review your differential calculus para hindi na kayo malito kung paano ginawa ito. And then if we simplify it, we have dy over dx equal to 0.4x e raised to 0.2x squared. So if we replace e raised to 0.2x squared in this equation by y from our first equation or from our original equation, we will have the differential equation dy over dx equal to 0.4xy. So again, this is now a differential equation. Now imagine a friend of yours simply hands you this differential equation and you have no idea. Okay? So wala kang idea kung paano siya ginawa. So your friend then asks, what is the function represented by the symbol y? Okay, so ano daw yung original function mo? Ano daw yung y? So you are now face to face with one of the basic problems in the course of differential equations. How do you solve such an equation for the unknown function y is equal to f of x? Okay, so when we are solving a differential equation, we are actually looking for the original function y. Okay, so free of any derivatives. So medyo similar siya dun sa problem natin sa calculus where we are given a derivative and then hanapin mo yung antiderivative niya. Again, the solution of a differential equation is a function which is free of any derivatives. So walang derivative dapat. And then when substituted to the given differential equation, it reduces the equation to an identity. So there are actually a lot of ways of solving differential equations. Depende sa type niya. And yun yung pag-uusapan natin in the next topics. So for now, para mas maintindihan nyo yung concept of a solution of a differential equation, let's solve the following examples. So first example, let us verify if the function y equal to x raised to 4 over 16 is a solution to the differential equation dy over dx equal to xy raised to 1/2. So from the first function given, y equal to x raised to 4 over 16, if we take the derivative of this function, we will have 4 over 16 x cubed, or that will be equal to x cubed over 4. Now, if we substitute this to our differential equation, again, our differential equation dy over dx equal to xy raised to 1/2. So if we substitute the values of y and dy over dx into our differential equation, we'll have x cubed over 4 equal to x times y, which is x to the 4th over 16 raised to 1/2. So again, we have x cubed over 4 equal to x, then x to the 4th over 16 raised to 1/2, so that will be equal to x squared over 4. And then further simplifying this, we will have x cubed over 4 equal to x cubed over 4. Therefore, the equation is satisfied. Therefore, the given function y equal to x to the 4th over 16 is a solution to the given differential equation. Okay, so for the next example, verify that y double prime minus 2y prime plus y equal to 0 has a solution y equal to xe raised to x. Again, to verify that the given function is a solution, let us see if after substitution, each side of the differential equation is equal or the same. So from the given solution, we have y equal to x e raised to x. And if we take the first derivative of the given solution, we have e raised to x plus x e raised to x. And then for the second derivative, we will have e raised to x plus e raised to x plus x e raised to x. So further simplifying this, we have for the second derivative of y, that will be equal to x e raised to x plus 2 e raised to x. So we now have the values of y, y prime, and y double prime. So let's substitute this to the given differential equation. So y double prime, that will be equal to x e raised to x plus 2 e raised to x minus 2y prime, which is equal to e raised to x plus x e raised to x plus y, which is x e raised to x. That is all equal to 0. So by combining like terms, we will have 2x e raised to x plus 2 e raised to x minus 2 e raised to x minus 2x e raised to x. So these terms will cancel out, these terms will cancel out, so we will have 0 equal to 0. Therefore, the given function y equal to x e raised to x is a solution to the differential equation. Okay, so that's it. Thank you for watching. See you on the next class.